For this module, we're talking about data visualization with colors. So we're going to be using the RColorBrewer package and talking about different palettes and how to select colors. So we're going to continue using ggplot2 to discuss several aspects of figure aesthetics that can be implemented towards creating those publication quality figures that we all need. So this is specifically discussing those color themes with that RColorBrewer package to select colors. This first part here is a review from the fundamentals of data visualization about colors specifically, so I'm going to talk about it a little bit. So color is a major component of visualizing your data, since we no longer just have to hope that in print that things look colorful or look distinguishable in black and white. We can actually use color since most journals are online at this point. And color choices matter greatly to correctly visualize your data and make the data understandable for the reader or audience or interpreter. So are there many plots that incorrectly show data because of the choice of color? For example, they'll show like precipitation with red, whereas at least in Western cultures, precipitation is associated with a blue color scheme. And it can be confusing to our brains if the colors don't match with well-known or well-established psychological links with things like precipitation or dryness might be red instead of wetness is blue, something like that. So we have looked a little bit at color previously by changing the colors of points based on aesthetics and global parameters, as well as by factors for bars and things like that. So, however, we didn't discuss the families of colors or how to select different colors because generally we just used our default to automatically choose a color palette to fill in the bars and points and whatnot. But we can better select the colors we want that actually are like colorblind friendly and don't clash as much as some of the colors that are in these palettes. So this is a review part from the fundamentals of data visualization, but as a refresher for color specifically. If you have a continuous scale of data where the data are unidirectional, so like precipitation 0 to 100, you want to show the data as one color family on a figure, so like blue, where the values of the data closest to 0 should be lighter blue. The values closest to like 100 millimeters or more precipitation should be a darker shade of that color, or vice versa, depending on what makes sense with the scale that you have. If you have a continuous scale of data where the data are multi-directional, so maybe you have dry to wet with 0 being like a neutral. So you have negative and positive values with 0 at that center, negative maybe being dryness and 0 being neutral, and then positive being wet. You want to show the data as some more similar color or complementary color families, but two different hues here. So like one hue might be red, which you would show for negative values, and the other one blue for positive values. So dryness would be red, wetness would be blue as an example. And then if you have related factor data, so these are categories like low, medium, and high. So they are related to one another. You want to show the data as one color family and then choose a lighter shade for low, a medium shade for medium, and a darker shade for high. So it might be all blues, it might be all greens, reds, etc. They should all be similar hue, different shades because they're related, and that implies relatedness to have similar color. And then if you have unrelated factor data, like maybe different habitats wildlife are located in, different species. You want to show those data as multiple color families because they're unrelated to one another. So you want to have something like a blue, a red, an orange, purple, like colors that don't necessarily indicate that they are related to one another. But however, these colors should not clash to create a very disgusting figure. So don't make them too bright, too um, not distinguishable. So selecting color is kind of a game to play at. And also keep in mind color blindness when selecting colors as well. So red-green color blindness is the most common one. So never put red and green on the same figure unless you've gone through a colorblind friendly palette and it has red and green that are different shades on it. Um, just don't do red and green generally. The RColorBrewer and online color selectors can help you find colorblind friendly color palettes or specific colors. And those are really helpful for being like, what does this look like in grayscale? What does this look like to someone with a color blindness? So we can get our figures looking correct for most people. We can, so there's multiple different ways to select colors in R. So we can select colors by naming palettes, naming individual colors like hot pink, chartreuse, red, black, or creating palettes and individual colors using hex codes, which is a pound sign followed by 6 numbers. And then, or using RColorBrewer. To see more information, you can click on these links to look a lot more at like colors with plots. But we're going to start with some of this coding and see what this looks like. So our first example with color looks at the outline versus fill of different figures. We talked about this very briefly in a different module, but it's very important to distinguish outline and fill. So fill is the color within the chart type, so within like a box, while color is the outline of that line. So for bar charts, you have fill, which is the coloring of the bar, and the color, which is the line around the bar. So we're going to load the tidyverse package and our fish data set, which again is community data from the long-term resource monitoring element of the Upper Mississippi River Restoration Program from a subset of 2008 and a subset of the fish assemblage. So this is just routine sampling fish community data. So for the first thing we want to look about for outline versus fill, we're going to use a bar chart as an example. To note, we want to note the difference between fill and color because these are very helpful. Fill fills in the blank space of a bar, point, or any other shape. Color always refers to the outline. So for this bar chart, for our ggplot, again, we specify the ggplot function, our data set, our aesthetic, or our variable we are mapping, which here is species because it's a bar chart, which uses stat count. So it's automatically going to count the sample size. So here we're making color equals black. So that's going to be the outline of the bar. We're making it size 1 for that color, and then we're filling in the bars with gray 40. What's nice in the newer versions of RStudio is if you have the color within the quotation marks, it will highlight the text in that color so you can actually get a preview what that color looks like. All right, we've got color black. All of our bars are outlined in black and our fill is gray 40, so they're filled in with gray 40. We could change this to whatever we wanted, goldenrod, for example, and that's all going to be black fill, goldenrod, or black outline, goldenrod fill. This size is going to change the outline size. So we increase it from 1 to 3 and we get a thicker outline around this. So just some of the aesthetics you can change for those bars. So whatever color you want, something that makes sense with your data or something that's not too horrendous. Things like the red are very hard to look at because they're very bright. Some of those basic colors like red, blue, yellow, they're very bright colors and they are hard to look at for long periods of time. So I'd recommend some of the other colors like goldenrod, which is a little bit more muted. It's not as harsh looking at. So here we altered the outlines of the bars, which is color, and the inside of the bars, which is fill. We can use the same fill and color principles to box plots and other types of plots as well. If for scatter plots, we have to use a shape that has open points, which are shape numbers 21 through 25. So we can look to see what that is. First, we're going to look at the box plots. Box plots, remember, we need a factor or categorical variable and a continuous variable. So we have our data set as fish. Our aesthetics, we're mapping our species on the x-axis or categorical variable, and our weight or continuous variable on the y-axis. And we're using a geometric box plot. We're going to make the color of the box plots black, so the outline of them black, and the fill gray 40. So all of our points, all of our lines are black, the outlines. And our box plots are filled in with gray. To note what everything changes when we change black, we can make them goldenrod. It changes the points, it changes all the lines for that outline, for that color, not just the lines themselves, it includes the points and everything too. Just to make sure we understand that. I like filling in box plots because it helps the data stand out from that white background. Otherwise, there is no fill. We delete that. Default is to just have it white. And it's fine, but I think the fill helps it stand out from that background quite a bit more. Draws your attention to the data a bit better. So if we do a scatter plot, we have to use numbers 21 through 25 for the shape. So here we're specifying our fish data set in the ggplot function. We're mapping length and weight. We need two continuous variables for scatter plot. Then we're saying geom_point for a scatter plot. We want the color to be black, so the outline of the shape to be black. Our shape is going to be one that has a fill option, which is 21 through 25. So we're choosing shape 25. We're changing the size of that shape. The stroke, so size and stroke here are a little bit different than some of the other geometries, where size is the size of the shape, and stroke now is the size of that outline. And we're filling it in with blue. So we'll see what this looks like. All right, we've got a black outline and a blue interior of all of our points. If we change stroke, I'm just going to go really big for this. We'll see what happens. It makes that outline super big. And if we change size, also we'll make it really big. It changes the size of the triangles here. So I would play around with a lot of these things and just be like, all right, what are some of these dimensions that we can change? Stroke 1 here, size 4, fill blue, different shapes. So just play around to see what works best for your visualization, color scheme wise, as well as like shape size wise for these different aspects. So that's some of just playing around with the colors where we are just specifying the fill or the color or both of these different geometries. So let's look at changing color schemes in R next. So you can create your own palettes using the RColorBrewer package. And following this is a very basic example of selecting the colors for palettes, and you can manually include hexadecimal numbers or the color names if you want. So load the RColorBrewer package. This first function here, the display.brewer.all, gives you all the palettes that are inherent in this RColorBrewer package. So if we look at that, the text is really smushed together in the output here, but we can see some of the colors and what those names are. His first one is yellow, orange, red, and it's a gradation from yellow, orange to red. And some of these are bidirectional or unidirectional colors. So This first group are the unidirectional colors, really, where you're going from a light to a dark. So those are really good for like increasing one directional data. These middle ones, these sets, dark to accent, pastels, etc., are good for unrelated data because those colors are just kind of mishmashed in there. So they're different for factors. And then the most bottom ones like spectral, magma, viridis, etc., are bi-directional data, where it's like a red on one side and green and blues on the other, reds and oranges, purples, etc. So they're very different from one another, but that gives you some of the set palettes that are inherent in R and their names. If you want to look at colorblind friendly ones, you use the same function display.brewer.all, would include this colorblind friendly equals true argument. And it's a lot fewer of those palettes, but these are all colorblind friendly ones that can be used in any plot. What's important to note is that when you have a bunch of factors or different variables you were trying to plot with a color, is it's going to bin your colors or it's going to make one color per factor. And if you have like 10 to 20 factors, which is a lot of different colors in a plot to begin with and not recommended, these palettes don't have enough colors in them already to map every single one of those factors to a color. So for example, like set two here has 1, 2, 3, 4, 5, 6, 7, 8 colors. So if you have more than 8 factors, you're going to have factors that don't have any color associated with them. So these are quite limited in the number of factors or variables you can have associated with these palettes. So just keep that in mind. So one thing is if you want to look at only one of the palettes, you can run this code to see what colors there are, the number, and you can see the number of colors within them that you want. It's display.brewer.pal. Here we're specifying we want 8 colors to come back from it, and the name of that palette is dark 2. These are the 8 colors within the dark 2 palette. And you can just see what those colors are then and see if you want to look at that because it's a lot easier to look this way than it is to look at like all of these where they're really small and smushed. If you want to see the hex codes for the palette, it's just brewer.pal instead of display.brewer. Again, we say we want all 8 colors. Name is dark 2. Those are the hex codes. And we will see what we can do with these hex codes moving forward, is that we can use them to specify colors within a plot specifically. So this is a way to get some of them. If we look at a yellow palette, let's say we want to look at the yellow, orange, red palette. These are the hex codes for yellow, orange, red, the first 6 values. We could change this to 8 if we wanted, and we would get 8 hex codes then. However many you need for however many factors you have, essentially. Here we're saving this as the object yellow. And if we run that, it's going to give us the 6 hex codes that we saved that object as. And we can use this in a function later to then have that be our new palette specifically. So this is how you can look at the specific palettes within this package, as well as the colors, like their hex codes and whatnot, within some of those palettes. So now we're going to look at changing some of the colors in our plots, and we want to alter the fill of the bars for our plot by field station. So we specify field by field station in the aesthetics because we want it to vary by a variable. And then we select the type of the position we want of our bars or columns to be in Dodge, and we're going to select a palette to show this. So this first part we've done before. We're specifying the fish data set. Our aesthetics are species on the x-axis. We are filling by field station. So we're filling those bars because we're specifying geom bar by field station. Because we're using geom bar with a default of stat count, it's going to automatically count count sample size of our different species, and we want those bars to be side by side so our position is dodge. Therefore, they're more comparable. So, all right, we got species on the x-axis. It automatically created a count of the individuals in each species, and these points are side by side, or these bars are side by side. It doesn't have anything for fill or field station here because we haven't specified what colors we want. So we're doing fill by field station. Actually, we need to make that a factor, and we could wrap that if we want. Let's see what that does. We need to make it a factor first for it to plot because we don't have it as a factor. It's just saying it's 1, 2, 3, 4, 5, 6, and that's numeric. That doesn't make any sense. So change it to a factor within here. And we use scale fill brewer. Scale underscore x underscore brewer is how we use the brewing color brewer functions. This is going to be color or it's going to be fill based on whatever our aesthetic is. So here it's fill, put fill here. And then we can specify our palette is dark 2, for example. So if this is the default colors without specifying our palette is dark 2, we now have dark 2 colors there. It just darkens those colors. All right, we've got this information here, and this is because we didn't have factors there. So if we don't specify this factor as our field station, we don't have any colors, we don't have anything side by side, we don't have those field stations in here. Shouldn't the bars be side by side with one another based on field station? And shouldn't the bars be different colors based on field station? So why are all the bars gray when we plotted this? So we need to look at the data to figure that out. And if we look at our data, we notice that field station is double, so it's numeric. And for us to color something by a factor, it has to be a factor in our data set, which is why I had specified as dot factor there. So what we can do is say, okay, we see that field station is numeric. It's a double variable currently, and we can only fill by factors, not numeric. So always check your data structure first, especially if you're getting something where you're like, it's supposed to be dodge bar charts and colors. Why is there nothing? So we're going to coerce the field station variable into a factor and try replotting. And to coerce, we can either use the wrapper as dot factor within the function here, like we had done up here in this plot where it was, we just put as dot factor and it's going to change just for this ggplot function. It now makes it a function or a factor that it adds that color in the dodged bar charts. But what else we can do and what we've done before in other modules is make it coerce into a factor for this session of R permanently, and we don't have to specify it in the different functions separately. And to do that, we say as dot factor within our fish data set, it's the field station variable. And we're just overwriting that field station variable. So if we glimpse our data now, field station is now a factor, and it still has the same values of 1 through 6, but it's now a factor instead of double or numeric. So we can now fill it in without having a wrapper there. So same exact code as before. And we now have this plot where everything's side by side and there's colors because you have to make it a factor. All right, if we change color instead of fill, we specify color here as field station. Everything else is the same other than changing scale fill brewer to scale color brewer. Remember, fill and color, we're just going to have the outlines be colored now, not the fill. The fill is going to be the same default gray. And that is scale color brewer versus scale fill brewer. That's important to note. So this is based on a preset palette in R. This is the plotting structure we expect. We have these dodge bars that represent the different field stations and species. Using color here is not as effective as fill for distinguishing among these bars, though. The color is the outline. That's not that easily interpreted compared to the fill, which is very distinct colors and very easy to distinguish among those bars. So if we talk about looking at some of these other ways to change color within here is if you want to use a grayscale palette, go all in and do that. If that's what you want to make it easily distinguishable with printing options or for some other reason, grayscale is a fine way to go. We don't need all these like bold colors here. What we can do is same exact code, species, filling by field station, bar geometry of Dodge. And now we're using scale fill gray, open parentheses, which is a specific function to do scale grayscale, and it automatically colors them by different grays. So this is a way, if you wanted to do grayscale, is viable without having to name the hex codes or names of all the grays. This is just showing you the different grays that automatically created. For some of these, it is hard to distinguish, especially for these lighter grays, like which one is which. So that's not the best way to do this. I wouldn't use grayscale like this unless you have only a few different factors. When we have 6 different factors here, it is hard to distinguish a lot of those grays from one another. But here we made each field station a different shade of gray using this scale fill gray art function. These values go from light to dark and are the same color family. So this color scheme is appropriate for related factor data. If we were saying that these factors, the field stations are related, which technically they are, but maybe that's not our story or our intended intention for our visualization. So these related factors seemingly from this grayscale may not be appropriate for separate entities like field stations or species. So think about that intention and the relatedness of your data when you are choosing color schemes. Another common one that's used is just blues. So these first 2 lines of code are the same code as before where we're making the dodged bar chart. Now we're using scale fill brewer. We're saying the type is sequence because we want them to be sequential. The palette is blues. Direction is one, which is regular order. In aesthetics, we are filling in because this is the aesthetic we had up here was fill. We're going to see what this does. We have blues going from really light blue for field station 1 to really dark blue for field station 2. If you change direction to -1, it reverses that, where it is dark blue for field station 1 and light blue for field station 6. So that's what direction means. Aesthetics fill, again, because we had fill for field station. Our sequence here, which we could see what some of these are. Type sequence, let's see. One of sequence, which is sequential, div for diverging, or qual for qualitative. So we could change some of these to be like diverging. Let's see if that does anything. This isn't a diverging color palette, it's just blues, so I don't think that's going to change that. What about qual? Same there. I don't think it's going to change it because it's a sequential color palette to begin with. Some of the other palettes we could do, we could change things. Yellow, orange, red. And we've got changes there from dark red to a light yellow. So you can change any palette here. I don't know if these change. No, I think it's just if we have certain palettes. But this is how you can change some stuff to be like, do you want to be sequential? Do you want it to be diverging or qualitative? What direction do you want this palette to increase up or down? And then what palette do you want? And this is just a way to further alter our palette instead of just saying like dark 2, maybe we want the direction to change. Maybe we want to specify what aesthetic we are changing. So if we go back to the blues, we'll notice that these blues are in sequence to one another, which indicates that these data are related in some way, which if that's not our story, this might not be appropriate for the discrete factor data. And what is appropriate is very different colors. So this is a way to fill colors with manually using the hexadecimals. So first two lines of code, same exact thing we have been doing. Dodge bar charts of each species by field station. Here we are manually scale, fill, manual, altering the colors. Fill again in the middle because we are filling by field station. With this manual choice, you specify your own values. So you're not specifying palette, you're specifying values. Values equal C for concatenate, and you will put all of your values in there for however many factors you have. For here, we have 6 factors, 6 field stations, so we're going to have 6 colors. And these are the hexadecimals, the pound sign and the 6 numbers or 6 letters combinations. For each color, the hexadecimals, just like the names of the different variables, show the color that they are. So we have this like purple, orange, yellow, blue, gray, and green. And these colors are not related to one another. They are separate and distinct, and they are much more appropriate for categorical data that are not related. They also are not super bright, hurting your eyes. They don't clash well, or they don't clash together. So these are much more appropriate colors. What I want to note is that you don't have to put hexadecimals here. You can put the color names. You could put like goldenrod here, and that would change one to goldenrod or magenta. Whatever colors you want, you can put them in there by the hexadecimal or names, or you can switch it up. So we have the name here, and then we have hexadecimals for the other ones. We can also take our yellow palette we saved earlier, and those are the hexadecimal codes from that, and we could copy and paste those into here if we wanted. And we can see their colors when we do copy and paste them, that they are yellow to red. Missing, oh, I don't have commas in between each one, so commas there. And then it's going to take the first 6 values you specify within this function, and it's going to use those colors. It's going to use however many colors there are first with how many factors you have. So since we have 6 factors, it's going to use the first 6 colors. So we can use those colors if we wanted, whatever works or whatever is of interest. So the above RColorBrewer functions are for discrete or factor data specifically. We are changing these color categories. But what if we wanted to change color by a numeric variable or some sort of gradient? So If we do our scatter plot of length and weight, for example, we are choosing a shape that can be filled in. We are making the color of the shape so the outline of the shape be black, affecting the size and stroke of the shape. And we're saying that the fill of the shape equals length of the fish. So this is a numeric variable in this data set. We are filling by this numeric variable. So what this looks like by default is it's going to create a legend that goes from light to dark or dark to light, however you look at it, that is shifting by a numeric variable. So the darker individuals are smaller total length, which, yes, on the x-axis there, and lighter blues are higher total length. If we don't want just like this blues palette or anything, what we can do is scale fill distiller. This distiller is for numeric continuous variables. The manual, the brewer for categorical variables. So this distiller, we can say palette equals, let's do the yellow, orange, red palette. And direction is 1 for increasing from light yellow to dark red. So now we have a more distinctive palette where we go from yellow to red. And this is a palette that's already set in R. We're just changing that. So scale fill distiller for continuous data. So we did this for continuous data. I want to note that adding color based on length doesn't really add anything to this plot because we already have length on the x-axis. But this is for demonstration purposes here. We can also make gradients among colors that are helpful for numerical continuous data as well. So same exact code for these first 2 lines. We're using that scatter plot of length and weight and varying the color or the fill of these shapes by length. To make a gradient, it's scale fill because we're filling by length, gradient n, and we specify our colors with the concatenate, and these are hexadecimals of different colors. Let's say we want 6 colors. So we're putting these 6 in here. I don't remember where I got these from, just 6 different colors. And now we have a gradient from this lighter green to a turquoise to a pinky purple. So it creates a gradient that we selected those colors from. We could do this with different colors as well. Oops. Let's say we want like black to red or something. So we say black, red. See what it does. Goes from black to red. It makes a very gradual color shift. If you are interested in anything like this can be very helpful. White to red, for example, like any colors you want. They don't just have to be like 6 random colors. They can be like 2 colors that you have a shift in. So now all these triangles are filled in by the length with graduated or a gradient of colors. I want to note that feel free to play around with the color schemes and color selection. This RColorBrewer website is a good tool to play around with the color selection. I can pull that up a moment. So I really like this website. Oops. Got the zoom thing in the middle there, blocking that. Okay. So I really like this website because you can do colorblind safe. You can do print friendly or photocopy safe things to show on here. You can look at the hex the RGB, which are not useful for us, but might be for some other code. But the hexadecimals, these are the actual hexadecimals that you'd put into R. And you can pick a color scheme of multi-hue, single hue, sequential, diverging, qualitative. Qualitative are your sets in R. This one's probably not colorblind friendly. Yep. It only gives you three sets then. The diverging schemes. And you can choose however many data classes up to 12. We'll have 11 here. And what this would look like. And it gives you the hex codes for every single one of these colors if you want to include them. So just this is a nice website to play around in so you can see what's going on. And with that, talked about our color brewer package today, how to select colors by names and hexadecimals and palettes, how to look at some of those palettes, and how to play around with our color brewer website to get some of those hexadecimals and look at colorblind friendliness and whatnot, as well as the difference between fill and color of a lot of these different plots. So with that, keep in mind the nuances and the fundamentals of data visualization, especially regarding color. Think about what type of data you have, whether it's related, whether it's factor, categorical, continuous, and what type of colors you need, and what's going to be easiest to visualize, as well as what makes sense with a visualization.